Hello, professors. My name is Ahmed Salim, and welcome to my presentation. The title of my paper: Detection and Classification Malicious URLs on Online Social Media Using Machine Learning. Introduction: The number of social media users has increased dramatically. However, some users are attacking and abusing of social media users.
Excuse me. Your screen share different. Not PowerPoint.
Not PowerPoint. What's okay?
Yes.
Okay. The title of my paper: Detection and Classification Malicious URLs on Online Social Media Using Machine Learning. Introduction: The number of social media users has increased dramatically. However, some users are attacking and abusing the use of social media by posting malicious URLs on online social media. The URL allows an attacker to gain access, control partial or full system. As a result of this cybercrime, theft of bank accounts, DDoS, and malware installation, as well as many attacks. Therefore, methods must be used to detect malicious URLs to protect social media users. Figure 1 presents an increased number of people using online social media. By in 2005, the number of social media users has been 0, and the number of social media has been increased dramatically in 2007 in Facebook to be 2 billion. Contribution: Identifying the most targeted feature of malware attack in dataset using machine learning technique. Proposing a method for detecting malicious URL. Proposing support vector machine algorithm to detect malicious URL activity on social media networks. Classify URLs into benign or malicious to reduce risks and threat social media users. Malicious URL. Malicious URL is a link created with the purpose of promoting attack and frauds. By clicking on infected URL, you can download ransomware, keystroke loggers, Trojan horse, or any other type of malicious that will compromise your machine or even your network. Type of malware. There are many forms of malware, and all of them can damage operating systems. Keystroke logger. It is a malicious software used to spy on the keyboard and be hidden. The keyboard monitor is considered illegal because it is associated with the cybercriminal to penetrate users' social media accounts and obtain sensitive data such as email, passwords, personal accounts, and credit cards. Attackers sends keylogger by private message on social media or bolt on website download program. Figure 2 present keystroke logger work. At the first stage, the attacker sends a encrypted injected link to victim by email or private message on social media. And the second stage, the victim click on link and request legitimate website. And the third stage, the victim browser load legitimate site, but also execute malicious script. Finally, malicious script send victim private data to attacker. Clickjacking malware is a malicious technique of tricking a user by clicking on something different from what the user receives. Thus, potentially revealing confidential information or allowing others to take control of their computer while clicking on seemingly not malicious object, including web pages. Phishing. A social media phishing attack is where the attacker uses our favorite social media, for example, Facebook or Instagram, to steal our personal data, usually by posting on a friend's page something that we cannot resist to click on it. Malicious spread in social media. In the first stage, the malware developer create one or more fake profiles and infiltrate them into the social media. And the second stage, the malware developer uses social engineering technique to create eye-catching web link that trick users into clicking on them. In the third stage, after the user is infected, the malware also posts the eye-catching web link on the user's wall, for example, via newsfeed or to recruit his hair friends. The malware will then post the malicious link on the walls of the newly infected users to lure their friends to the web page that hosts the fake video player. Figure 3 presents example of malicious URL spread in social media. In the first stage, Johan Smith post the new post, hi guys, this is behavior unacceptable, and his content the URL malicious script. When the user clicking on the URL, he will see the amazing video, and he will click on the download. When the user click on the download, he will be victim to the attacker. Uniform resource locator. A URL is a uniform resource locator. The name given to the web page are referenced and found using web browser. URL is made of several parts. Protocol, usually used http:// or https://. This tells the web browsers to expect web address to flow. Domain, this is the highest level part of a URL website name, and you can think of it as the computer on which the web page is stored. In reality, the domain is probably made up of many computers, especially for large domains accessed by many people. But this is as the folder structure of the website. So a browser now which the subfolder to find the web page. This is the last part of the URL, and is the specific large, and it's the specific page you are requesting. Figure 4 presents example of URL structure. HTTPS Hypertext Transfer Protocol Secure. This is protocol of the URL, and the www subdomain of the third level domain, and the domain name will be content second domain and top level domain. Dataset. The dataset used in this experiment in the form of a comma separated value, CSV. This is contain malicious websites and other benign websites. The total of the dataset is 13,002, and the number of malicious sample is 6,500, while the number of benign sample is 6,502. The dataset is obtained from Kaggle community, which is a free dataset. Figure 6 present label 0 refers to malicious URL and 1 for benign URL. The proposed method, collecting of benign URLs and malicious URLs in single CSV dataset, split the URL in token, extracting feature from tokenized URL, split data into training and testing, classification with algorithm support vector machine. The result, figure 7 present confusion matrix for support vector machine. Classification compression. Algorithm nav buys 98%, and logistic regression 88%, and support vector machine 93%. Conclusion: in this work, a predictive model is developed to identify URL that point to malicious URL using the URL-based feature. The literature review of previous study showed the security threat that occurred through the malicious URL. Therefore, the most appropriate feature was used to build this model. Support vector machine algorithm was optimal for detecting malicious URL through the selected feature. The model was successful in classification URL into malicious or benign with high accuracy. Security recommendation: not open any URL or download files from unknown users on social media. Not visit compromised or insecure websites. Not click on pop-ups and use services that show confidence level of the website. Example of that, weboftrust.com. Thank you.